Welcome back. We have an interesting topic for today. Post-training of an AI model. What is it? Models are already trained. Why do we need post-training? So let's look into that in detail. When a modern AI model is first created, it begins life with an unusual kind of brilliance. It has read trillions of words, digested libraries of text, mapped out the patterns of human language. Yet, for all this intellectual horsepower, the model doesn't actually know how to talk to us. It doesn't know how to follow instructions. It doesn't know how to hold a conversation. It certainly doesn't know what we consider as good, respectful, or acceptable behavior. So, in its earliest state, a pre trained model is nothing more than a highly sophisticated completion engine. Given a sequence of tokens, it predicts the next token in the sequence. That's all. And because this stage is trained on vast amounts of data scraped from the internet, the raw model inevitably picks up the internet's full spectrum of content. Profound sometimes, insightful sometimes, misinformed a lot of times, angry, offensive, random, everything in between. So this is why pre-trained models on their own are unusable. To transform them into assistants capable of reasoning, dialogue, and helpfulness, they must undergo a crucial second stage. This second stage is called post-training. So let's look into it from how does a model go from a completion machine to a natural conversation with a user. So pre-training gives a model language, the details, the construct, the grammar. Post-training gives it its behavior. The goals of these two phases could not be more different. What I mean is, pre-training optimizes the token level quality. At an individual word level, it optimizes how precisely it can predict the next word. The model learns to predict the token accurately. Whereas in post-training, we optimize it for human preference. So the model learns to respond in ways that users might find it more helpful, more respectful, safe, and aligned with what we expect from an assistant. The difference between the two is the difference between a dictionary and a teacher. The pre-trained model is a full-fledged dictionary. It has all the words in the world. It knows the relationships. It knows the grammar. But does it know which one to use when? That's what makes a good teacher, right? One provides knowledge, the other one provides guidance. So why is post-training necessary? It's very simple. Imagine asking a raw pre-trained model, explain quantum mechanics to me like I'm a beginner. Without post-training, the model might ramble without focus because it knows a lot. It produces a wall of text. So this is all similar to us humans, where if we are bombarded with too much of information, we know all the words, all the concepts, we have a lot of information, and we are not given enough time to construct our concepts, ideas, what is right and how do we express it. That is exactly how a pre-trained model without post-training would behave. It produces a huge amount of text, maybe incorrect explanations. It might know a lot, but still, it needs some guidance to put it in the right context. And worse, if the training data contains toxic or biased text, which it always does on the internet, there is always bias. The model might reproduce these patterns without understanding why they are harmful. So this is the fundamental limitation of self-supervision. The model learns patterns, not principles, language, not values. So to correct this, we must train the model to behave appropriately. So let's look at the first one, which is supervised fine-tuning. This is teaching the model to follow instructions. The first layer of post-training is called SFT, or supervised fine-tuning. Here the model is fed thousands of carefully constructed instruction response examples written by experts. So examples are like this. Let's say translate this sentence into Hindi, which is a high quality translation, or write a polite email declining a meeting, which is a well structured response. So these curated examples reshape the model's behavior. The raw model, which previously only predicted the next token, now begins to understand what a conversation should have. It learns to respond directly to the user's intent, not just the preceding text. So SFT turns the model from a basic autocomplete system into an instruction following assistant. But that is still only half the problem. The bigger challenge: what conversations should the model have? A model capable of assisting with writing, coding, or reasoning is also capable of generating harmful advice unless we explicitly teach it to avoid such content. So this creates a philosophical dilemma. If a user asks a discriminatory question or requests instructions to cause harm, how should the AI respond? There is no universal answer. Different cultures disagree. Different societies have different norms. What one group considers as offensive, another might view as a form of free expression. So it's really hard to come up with a balanced model. If the model is too strict, users will feel that the model is very censored. If the model is too loose, it becomes unsafe for deployment, right? So finding this balance is not simply a technical challenge, it is a cultural one. So this delicate balancing act is achieved through the second major part of post training, which we call as preference fine tuning. So let's look at what is preference fine tuning. This is basically aligning the behavior with human values. Preference tuning teaches the model what kind of responses humans prefer. Unlike SFT, which provides very clear, explicit examples, preference tuning teaches subtle judgment. Which answer is more polite? Which tone is more appropriate? Which explanation is more precise? Which responses avoids harm? But how do we teach a model something as vague as preference? There are two major methods today, RLHF and DPO. So reinforcement learning from human feedback. I think we referred to this in one of the episodes. This was a breakthrough method that made early conversational AI possible. The process works in three major steps. First is to collect comparison data, then train a reward model and optimize the base model using reinforcement learning. So let's look at collecting comparison data. Humans, let's say we call them labelers, they are shown two model responses to the same prompt and asked a simple question: which one is better? If you have gone through ChatGPT from its early days, there are many times where ChatGPT shows you two responses and asks you to choose which one is better. So comparison is easier and more reliable than giving numerical ratings. If we ask the human labeler to rate a response on a scale of 1 to 10, it might make it a little more complicated and which may not be very scalable. But comparison is more reliable. If I look at two answers, it is more easier to say I like this answer or I don't like this answer. So that is collecting comparison data. Then we have train a reward model. So this is a separate reward model which learns to predict which responses humans are likely to prefer, and this reward model is integrated into the overall responses. And the last part is optimizing the base model using reinforcement learning. So the AI is encouraged mathematically to produce responses that the reward model rates very highly. So it's like a monitor or a supervisor which is looking at how the model is responding with text and responses, and the rewards model will basically punish the model or reward the model. So this process kind of nudges the AI towards helpfulness, politeness and safety. But RLHF is resource intensive. Remember, there is a human in between. Human comparisons can take up to 5 minutes each, especially when fact checking is necessary. I mean, this is statistics. It could be more based on how complex it is, or it could be simpler, but 5 is statistically an average. So despite all this effort, it is nearly impossible to capture the diversity of global human values. What I consider as value may not be useful in some other culture, and vice versa. So let's look at DPO, direct preference optimization. This is a newer approach. DPO simplifies the entire process. Instead of training a reward model and running reinforcement learning loops, DPO directly trains the model to prefer the winning response over the losing ones in comparison data. So think of DPO as RLHF without the RL, without the reinforced learning part. So it is simpler, more stable and requires fewer resources. As a result, DPO is becoming a popular alternative in modern AI systems. So post-training is a small but transformative step for the model. One of the most surprising truths in AI development is that post-training consumes only a fraction of the resources which is required for pre-training. Pre-training runs for weeks or months on thousands of GPUs. Post-training runs for a few days. And yet, it is post-training that makes the difference between a raw model that predicts text and a refined model that behaves like an assistant. So that transformation is dramatic. So pre-training teaches grammar, facts, reasoning, all of those things. Post-training teaches helpfulness, safety, politeness. So it is the post-training is the bridge between raw intelligence and practical usefulness. So post training is not a solved problem. Human preferences evolve, cultural norms will shift. Users expect more nuances, more empathy, more consistency. And because humans disagree among themselves, a universal standard for AI behavior may always be out of reach. What you consider as the right thing may be wrong for me, or vice versa. However, the goal is not perfection, but rather practicality, something that most people agree on. Post training makes AI models usable in the real world. It gives structure to their intelligence and a little bit of direction to their abilities. So, it is this stage where they stop being statistical machines and they start becoming companions, assistants, collaborators, reasoning partners, all sort of variations. So, in many ways, post training is the moment where AI becomes more than a model. It becomes something capable of participating in the human world. Tell me what you think in the comments. I hope you are enjoying these episodes. We'll go on to the next topic in an hour's time. So, see you soon. Thank you for watching.